Hi, I'm Alex.
And I will introduce you to our universe. Let's start with a part of our planet, the tallest one, Mount Everest. Beautiful, isn't it? But that mountain is just a teeny tiny part of our planet. Here with the clouds, we can only guess where is it. And yep, my cursor can cover it. Closest natural celestial body is an Earth satellite, Moon. It is one of the biggest moons in our solar system, making the Earth quite unusual planet. And here is the famous Earth photo taken by one of the astronauts who visited Moon. We look small, don't we? Our star, the Sun. Astronomers classify it as a G2 class star. Translated, that means the star is in the middle of the star sizes and temperature ranges. Sun is big. If we align all planets next to each other, they would take up only the area covered by this arrow. And talking about planets, our Earth is a small planet. It's just a fifth in the size, starting with Jupiter as the largest one. Venus, Mars, and Mercury are smaller than Earth in that order. But that's not all. Our Sun is just another small star in a group of stars we call galaxy. You can see our own galaxy if you go camping somewhere far away from cities and light pollution. This is how a galaxy looks like from outside. Sun is approximately here, in one of our galaxy's spiral arms. You could maybe be able to identify the Sun on this distance, but Earth it will be invisible. And if you're tricky, that is where approximately would be alpha and beta quadrants. When you look into the sky, some of the shiny objects are different galaxies. The one closest to us forms something called local galactic group, and at this distance, our Sun is invisible. Our group has two big galaxies. Ours, Milky Way, and Andromeda. And for the fans of Stargate, here is the Pegasus galaxy. And it's called local because when we zoom out, there are much more galaxies around. This is so-called Virgo supercluster. A bunch of local clusters hangs out together, drawn by something called the local attractor. Here, at this distance, we could detect our galaxy, simply because there are only two large galaxies in our local cluster. But wait, there's more. Even superclusters are just parts of a bigger whole. At this distance, we can see that our universe is more or less isotropic, meaning the same in all directions. This isotropy is visible when we glance at the observable universe. In truth, we don't know how big our universe is, because of the very strict speed limit on the light. At this particular time, we see only this part of the universe, because the light from those sources reached us. See, looking up into the sky is looking into the past. Every single photon, a tiny part of light that reaches us, was emitted a long time ago from its source. Even light from our Sun takes around 8 minutes to reach us. And yes, we have our universe baby pictures. This is one of them, so-called background radiation. But things are even more complicated. Cosmologists consider our universe to be just one of many, and there were experiments that confirm existence of the multiple universes. One of the experiments found evidence of bruising in the background radiation images. Basically, our universe collided with another universe, and that collision left something like a bruise.